Hello everyone. Welcome to the How To Academy, your online school for everything you want to know, made easy. In today's episode, we're going to demystify the fascinating world of semiconductors. Now, let's get started. When you think about the backbone of modern technology, semiconductors often come to mind. They're the crucial components of many electronic devices you use daily: your smartphone, computer, TV, and much more. But what exactly is a semiconductor? Let's dive in. A semiconductor, as the name suggests, is a material that has a conductivity level somewhere between conductors like copper or gold and insulators like glass or rubber. The key to its utility lies in this semi-conductivity, which we can manipulate under different conditions. Think of it this way: in a city full of cars, electrons, conductors are like highways with no speed limit, allowing cars to move freely at high speed. Insulators, on the other hand, are like blocked roads where no car can pass. Semiconductors? They are like city streets, where the traffic, electron flow, can be controlled under various circumstances. Now, let's talk about types of semiconductors. First up, we have intrinsic semiconductors. These are pure semiconductors without any significant impurity. Silicon and germanium are two of the most commonly used intrinsic semiconductors. These elements have 4 valence electrons which form covalent bonds with their neighbors, creating a stable lattice. At absolute zero temperature, these semiconductors behave like insulators. However, as we raise the temperature, the thermal energy causes some electrons to jump from the valence band to the conduction band, leaving behind holes in the valence band. The movement of these free electrons and holes is what allows intrinsic semiconductors to conduct electricity. Moving on, we have extrinsic semiconductors. These are semiconductors that have been doped, that is, we've intentionally added impurities to change their conductive properties. Depending on the dopant, we get 2 types of extrinsic semiconductors, N-type and P-type. N-type semiconductors are created by adding pentavalent impurities like phosphorus. These impurities have 5 valence electrons. 4 of these bond with the semiconductor atoms, and the extra electron is free to move, increasing the conductivity. P-type semiconductors, on the other hand, are created by adding trivalent impurities such as boron. These impurities have 3 valence electrons, resulting in a hole that is free to accept an electron. This movement of holes is what makes P-type semiconductors conductive. When we join these 2 types of semiconductors, N-type and P-type, we get a p-n junction. This junction forms the basis for simple semiconductor devices like diodes. A diode allows current to flow in one direction, from the P-type anode to the N-type cathode, but not in the reverse direction. When voltage is applied to the diode in the forward direction, the electrons and holes move towards the junction, recombine, and allow the current to pass through. In the reverse direction, the electrons and holes move away from the junction, creating a depletion zone, thus blocking the current. Using these principles, we've been able to build more complex semiconductor devices. One of the most important ones is the transistor, which can amplify or switch electronic signals, serving as the foundation for all digital circuits and modern computing. Integrated circuits or microchips are another leap forward. By miniaturizing thousands or even millions of transistors onto a single chip, we've been able to build complex computing systems that fit in the palm of our hand. It's difficult to overstate the importance of semiconductors. They are the brawn in our electronic devices, from laptops and smartphones to cars and home appliances. They're also at the heart of telecommunications, the internet, and a wide range of technologies including satellites, solar cells, and medical equipment. In the end, the magic of semiconductors comes down to control. By understanding and manipulating the behavior of electrons within these materials, we've revolutionized technology and shaped the modern world. It's a huge topic, and there's plenty more to explore. If you're interested, check out our follow-up videos where we delve deeper into topics like diodes, transistors, and integrated circuits. That's it for today's lesson at the How To Academy. I hope this has helped clarify what semiconductors are and why they're so crucial. Don't forget to like this video if you learned something and share it with your friends who might be interested. Don't forget to subscribe and hit that notification bell so you don't miss any of our future lessons. As always, we appreciate your support. And remember, keep asking questions and keep learning. Goodbye for now, and we'll see you in our next video.